Hello, I'm Ben, and I'm a curriculum developer from Boston. In this video, I'll be walking you through the Codecademy store project from the Learn Redux course. In this project, we'll help implement a Redux state management system for a program that mimics Codecademy's own online store. In order to follow along with the steps, you'll need to be familiar with JavaScript fundamentals, such as creating arrays, objects, and functions. You'll also need to be familiar with creating and rendering React components, as well as using the core Redux API methods createStore, combine reducers, and the store methods getState, dispatch, and subscribe. All right, let's begin. We can see here what we want the end result of the program to look like. Inventory items are displayed with their prices. We can add items to the cart, adjust their quantities, and choose a currency. And at the bottom, the total is calculated. To help you get started with this project, we've implemented most of the React components that you'll use. We've also designed the state structure. This application will have 3 slices of state: inventory, cart, and currency filter. Here's an example of what the application state might look like after a few actions have been dispatched. As you can see, the inventory is an array of objects, whereas the cart is an object connecting items with their associated price and quantity. Lastly, the currency filter is a string. Take a moment and study this example, and feel free to return here anytime to refamiliarize yourself with this state structure. Implementing all 3 features of this program would take quite some time, so instead, it'll be up to you to just implement the cart feature by defining action creators and the reducer to handle the state.cart slice. It'll also be up to you to combine the slice reducers to create a store object, and then pass the store's resources down to the React components to render the state data. Lastly, we'll make sure to dispatch changes to the state when the user interacts with the components, and re-render the application when those changes occur. Let's get started. Before we begin, I'm going to resize some of these windows. We won't need the output panel for the first few tasks, so I'll minimize that. And we also won't need the output terminal for most of this project. It's only there in case you run into any errors. The first step towards implementing the cart feature will be to define the actions that can change the state.cart slice and to handle them in the reducer. Here we have the cart slice.js file open, and we can see that the add item action creator has already been created for us. We also see the cart reducer, which can already handle the add item action. If you'd like, you can pause the video and take a moment to look at how items are added to the cart. In addition to adding items to the cart, the user should be able to modify the quantity of each item already in their cart. First, let's describe this interaction by creating an action creator called changeItemQuantity. Below the addItem function, we'll start by declaring a new function called changeItemQuantity. It should have 2 parameters, name, which is the name of the item to change, and newQuantity, the new quantity for that item. And it should return an action object with a type and payload property, as all action creators do. And the payload should contain the name and new quantity of the item we want to change. Lastly, we'll export this function. All right, let's get into it. First, I'll create and export this function. So export const change item quantity. Obviously, there are multiple ways that you can create functions, but here I'm going to use the arrow function expression approach. And as the instructions say, we need a name and new quantity argument. And the name, again, is going to be the name of the item I want to change. And new quantity would be the new quantity. So just for example, if we go back up to the state, we can see maybe we want to change the hat quantity to 1. In this case, name would be hat, new quantity would be 1. Now, like all action creators, this should return an action object with a type property describing that action. The type property will always be a string that starts with the slice of state being modified, so cart, and then the name of the action, changeItemQuantity. In this case, this action also will have a payload because we'll need to tell the reducer the name of the item to change and the new quantity for that item. So I'll package these together in an object with the name and new quantity values directly passed through. Now, if you're unfamiliar with this syntax, this is the same as writing name, name, and new quantity, new quantity, where the values are stored in these variables, but I can just pass them directly through without using the colons. All right, let's move on to our next task. Now that we know what changeItemQuantity actions will look like and what payload they'll carry, we can handle those actions in our cart reducer. If we scroll down, we can see that a case for this action has already been started for us. First, the name and new quantity data is extracted from the payload, and then we use that name value to extract the item to update from our cart object. So again, let's say the name of the item we want to update is hat. Then the item to update we extract from the cart object will be this object here, price $15.99 and quantity 0. Again, we're trying to change the quantity of this value here. But remember, we need to do this immutably. So below the variable item to update, we'll create a copy of this item and then modify that item. So here we'll start by creating a variable called updated item. And this updated item is going to be an object, just like item to update. And we're going to copy the contents of item to update using the spread syntax, item to update. So we'll copy price $15.99 and quantity 0 into our updated item. And we want to change the quantity value. So I'll explicitly write quantity, colon, and then the value is going to be the new quantity that we got from the payload. Now the third and final step is to return the new cart state with this updated item included. If you need some help understanding how you can do this, we can take a look at how we add a new item to the cart in the add item action. Here you'll see that we return a new object where the contents of the cart is copied using spread syntax, and then we use the name of the item to explicitly set the new item object. So here we're going to return a new object, copying the contents of the cart state, and then using the name value to explicitly change that value to the updated item. Let's save our code and recap what we did in this step. In this task group, we started by adding a change item quantity action creator. We set its type by defining the slice of state that we're changing and the action that we're taking to change that slice, and then including a payload with the data needed to make that update. We then handled that case in our reducer by grabbing the item that we want to update, making a copy of that item and updating the copy, and then returning a new state with our new item included. Let's move on to the next group. With the reducers and the action creators ready to go, now we can set up the store. Here we'll open up the store.js file, and I'm going to close the cart slice.js file since we're no longer needing it. At the top of this file, we'll start by importing the two functions from the Redux package used to create the store object, create store and combine reducers. Since these are two named exports, I'm going to use the curly brace syntax and import create store and combine reducers. And you could have done it in the other order, that's fine. And this is from the Redux package. Now, ordinarily, if you're doing this on your own, remember you'll need to install the Redux package into your workspace by running the npm command npm install Redux. Now, the store needs a single root reducer to operate, but currently we have 3 separate slice reducers for each feature of our program. For now, we'll start by importing each of these reducers into our file. So we'll add 3 import statements, 1 for each slice reducer. Let's start with the cart reducer that we just created. So here I will import cart reducer from, and to figure out the file path from store.js to that cart reducer file, we can look in our file system. First, I'm going to locate the store file, which is in the app folder of our source folder. And to go to our cart folder, we're going to need to go up 1 level into our source folder. So .. That's how you go up 1 level. Then we're going to need to go down into the features folder, features, down into the cart folder, and then into that cart slice.js file that we were just editing a moment ago, cart slice.js. Using that same pattern, we can import the other reducers. So I'll just copy and paste those a couple more times. Next, we can import the inventory reducer. Then instead of referencing the cart features folder, we'll reference the inventory feature folder, and then the inventory slice file. And lastly, we can do the currency filter reducer using the currency filter features folder and the currency filter slice file. Now that we've imported all of the resources needed, we can combine the various slice reducers into a single root reducer using the combine reducers method. Then that root reducer can be used to create the store object. So first, let's combine the reducers using combine reducers. So I'll call combine reducers with an object as the argument. Remember, this object will map each slice reducer to the name of that slice. So for example, the cart slice will be mapped to the cart reducer. The inventory slice will be mapped to the inventory reducer, and the currency filter slice will be mapped to the currency filter reducer. Now this entire function call will return the root reducer, which we could save in a variable like this, or we can just pass it directly into createStore. So here I'm going to call createStore and pass this entire function call inside as an argument. Now createStore is going to return our store object. So const store equals createStore, and we want to make sure that we export that resource. I'll go ahead and save my code, and let's recap what we did in this task group. In this file, the main objective is to create and export the store Redux object. We did this by using the createStore and combine reducers method, which takes an object of slice reducers that are mapped to the slice of state that they manage. With the Redux store object created and exported, we can use its data in the rest of our application. Here I've opened up the index.js file. This file is known as the entry point for the application because it's directly loaded by the index.html file, and it's responsible for rendering the top-level app component. As you can see, the app component is already being rendered using the React DOM API, but it's missing data from the store. First, let's import the store into this file. Here we're going to use the import store syntax. Again, this is a named export, so we use the curly braces. From, and just like the app component, which is in the app folder, we can use the same file path /app/store.js. And if you want, you can take a look at the file system. We can see that both app and store.js are stored in this app folder. Now with the store imported into index.js, we can now pass its data into our app. The app will need access to two key pieces of data: the current state of the store to render the most up-to-date data, and the store.dispatch method in order to request new data when the user interacts with the app's various features. If we take a look at the app.js file, we can see that it expects two values passed in through props, state and dispatch. So first, in our app component, we'll pass in a state prop, and its value should be the current state of the store, which we can get using the store.getState method. Next, we'll pass in a dispatch prop. And in this case, we're just going to pass in the dispatch method itself. Notice that I'm not calling the method here. At this point, we can run our program, and we should see the currency button and this "sorry, no products are currently available" rendered to the screen. As you can see, there are no products being rendered, and I can't actually change the currency. In the next step, we'll fix that. Our application isn't re-rendering when we click on these buttons because we haven't set it up to re-render in response to state changes. Similarly, the products in this page aren't being rendered yet because the product data is only fetched after the page first loads. We can see this in the inventory.js file. Let's briefly explore that feature here. So we'll go into the features folder, inventory, and then inventory.js. At the top of this component, we can see that we dispatch a load data method when this component mounts into our application. We need to make sure that when any state changes are dispatched, the entire application is re-rendered with this up-to-date data. We can do this by subscribing this render method to changes to the store, using the store.subscribe method and passing in the render function as a callback. Now I'll save my code, and we should see the products rendered to the screen. In this task group, we integrated the store into this top-level app component by passing along the current state and the dispatch method when we render the application. Additionally, we subscribe this render function to re-render any time that the state changes. Now in the last step, by passing in this data, we were able to get the currency and the inventory features to render. But notice that the cart component is missing. If we take a look at the app.js file, we can see both of those components being rendered, but no cart component. Let's add it in. At the top of this file, we'll start by importing the cart component. Following the same pattern as these import statements, I'll use this same file path here. But then I'll need to change the folder to cart and the component name to cart.js. Now we can add this cart component into our app component's render statement. Here, below the inventory, I'll add a cart. And we'll need to pass in the proper data values through props. Like each of these components, the cart component will need its slice of data. So we'll pass in a prop called cart, and its value will be state.cart. The cart will also need to know the current currency filter value so that it can properly calculate the total. So we'll pass in the currency filter as well. And lastly, we'll also pass in the dispatch method. In this task group, we added the cart component to the application, passing along data from the current state and the dispatch method. It's fairly common for the app component to be used in this way. It's simply acting as a middleman to receive the store resources and distribute them to the presentational components. This approach is called props drilling and can be avoided using the React Redux package, but for now, it'll do. We can now see that the cart component is being rendered in our application at the bottom. However, as we can see, if we try adding items to the cart, they won't actually show up. Instead, we just see this replace me and $0 in the total. Let's fix that. Let's start by opening up cart.js, where the cart component is defined. As we can see, this cart component receives 3 props: the cart slice of state, the currency filter slice of state, and the dispatch method. Now let's take a look at the return value to see what this component renders. Here we can see that the cart container is trying to render the data in this cart elements variable as an unordered list. Currently, that variable is storing the string replace me. Instead, we want cart elements to be an array of list item elements created using this create cart item helper function. You can see that this function accepts the name of a cart item and then returns a list item with that data. Now, in order to create this cart elements array, we need to remember that the cart slice of state is an object, where each key is the name of an item added to the cart. For example, this cart might have a hat, a t-shirt, and a hoodie. In order to create our desired cart elements array of these cart items, we can first initialize cart elements to be an empty array. We can then iterate through each of the keys of the cart object and call create cart item with each of them as an argument, storing the results into the cart elements array. Let's go ahead and do this. So I'll start by replacing this with an empty array. And then below, I'll create a for in loop to iterate through the elements of the cart. So for let item name in cart. And for each item name, I'm going to call create cart item, passing in the item name as an argument. And then I'm going to push the value returned by this function call into the cart elements array, like so. I'll save my code, and let's test it out. Now when I press add to cart, we should see these values added to our cart as list items. Now before we move on, let me show you a more elegant way of creating this array from the cart object. This will follow a pattern that you'll see quite often while you're programming, and it looks like this. What we can do is we can take this cart object, and we can generate the keys of that cart object using the object.keys method. This function here returns an array of those keys, which means that we can use array methods like map to iterate through each value of this keys array, and we can call create cart item for each one. This entire line of code will return the exact same array generated by this process. So we can just say const cart elements equals, and then this line of code. Now we've achieved the same thing, but only in one line of code. And let's just test it out to make sure it still works, and it does. Now that we can add items to the cart, you may think that we're done, but there are a few things that are still not working. Most obviously, the cart total is not being updated with the right value. At the top of this cart.js file, we can see that we import the calculate total helper function from this utilities/utilities.js file. Let's take a quick look at what that looks like. If we go into the source folder and then into the utilities folder, we can see what this utilities.js file is all about. Here is that calculate total function, which accepts the cart and the currency. Now in our cart component, we can use that function to calculate this total value. So here we're going to call calculate total, and we're going to pass in the cart slice of state and the currency filter slice of state that we received through props. I'll go ahead and save my code. And let's try again. Here we'll add a few items to our cart, and already we can see that the total is being recalculated. Let's see if we can change the currency, and it works. Now, while we can add items to our cart and the total will reflect the items in the cart, we can't actually change the quantities of these items from the cart. As you can see, choosing new quantities for these items isn't updating the store, and the application isn't re-rendering. Let's take a closer look at how each cart item is created. We can see that create cart item returns a list item that includes this selector. That's what this number selector is. The onChange handler is defined to call onInputChange handler, that function defined at the top of the file, passing along the name of the item to change and the value of that number picker. Let's take a closer look at how this function is implemented. After receiving the name and the input, and then doing some data validation and normalization, it should dispatch an action to update the data for that item. Now, what action can we dispatch when the user changes the number value for an item? Change item quantity, that same function that we defined at the beginning of this project. So at the top of this file, we'll import the change item quantity action creator. Import change item quantity. And I'll import this from the cart slice file, which is actually in the same folder as cart.js. So I'll say /, meaning in the same folder that I'm currently in. We'll import from the cartslice.js file. Go ahead and save my code. And now that I have this action creator imported, we can dispatch it from the onInputChange handler. Here I'll use the dispatch method passed in through props. And I'll use the change item quantity action creator with the name and the new quantity as arguments. Now let's try adding a few more items to our cart. And let's see if we can update those quantities. It worked. Well done. You've completed the core functionality of this application. Now before we move on to the extra challenge, let's recap what we did to build this application. We started out in CartSlice.js, where we defined the action creator change item quantity. This action creator would later be used in our cart component to change the quantity of a cart item. We then defined how change item quantity actions would be handled by our cart reducer. We remembered to perform immutable updates by using spread syntax to make copies of the existing cart state rather than directly manipulating that cart value. In store.js, we imported all of the slice reducers for each filter of our application. We then used the combine reducers and create store methods imported from the Redux library to create and export the store, which is used throughout the application. In index.js, our entry point for the application, we imported that store object and passed along its data to the top-level app component through props. We made sure to get the current state of the store using the store.getState method and passed along as a state prop, and then the store.dispatch method we passed directly through as a dispatch prop. Now we did all of this inside a render function, which we subscribe to the store, meaning that our application is going to re-render anytime a state change is dispatched to the store. In app.js, we first imported the cart component from the cart features folder, and then we rendered it in the return statement of this app component, passing along its slice of state, the currency filter slice of state, and the dispatch method. With this approach, the app component acts as a middleman, receiving the state data and the dispatch method and passing it along to the presentational components. And finally, in the cart component, we took the cart and currency filter data passed through props, and we rendered that data using some helper functions, create cart item and calculate total. Lastly, after adding some items to the cart, we were able to dispatch our change item quantity action creator to the store, thus updating the state any time that we change the quantity of an item. As a final challenge, let's try implementing a search bar that will allow us to search for items in the inventory. Let's take a look at the hint. Here we can see that the search term directory has already been created for you. And we can see that right here in the features folder. Let's open it up and we can see that some files are already there for us. The search term component is already completed. But the search term slice file needs to be written completely by us. It will be up to us to complete this file by creating and exporting the slice reducer and action creators. We'll then need to add this slice reducer to our root reducer for the store. And lastly, we'll need to render this search term component in the app component with the appropriate data. Let's get started. First, we'll start with the search term slice file. First, we'll need to create a function called search term reducer that can handle the following action types: set search term and clear search term. Don't forget to set the initial state and return the state by default. We'll also need to create action creators, set search term and clear search term. Let's start with the action creators, since those will likely be a little bit simpler. Remember, every action creator is just a function that returns an action object. And every action object should have a type value. Type values are constructed by using the slice of state, so in this case search term, and then the name of the action. Some action creators will receive data and pass it along as a payload. In this case, we should accept the term that the user types into the search bar, and then pass it along to the reducer as a payload. The clear search term action creator will be similar to this, so I'll just copy and paste it. And then I'll change its name and update the type. When clearing the search term, we'll always want to set the search term to just be an empty string, so we don't actually need a payload. And we don't need a parameter. Now lastly, let's create the reducer that can handle each of these search types. So at the top here, I'll create a function called search term reducer. Notice that I'm exporting each of these values. And remember, every reducer should receive two arguments: state and action. We also want to create an initial state for this value, const initial state, and in this case, the search term will start out empty. Next, recall that reducers use a switch statement, or an if-else statement, to switch on the action.type value. Each case of this switch statement will be a different action type that this reducer can handle. This reducer should be able to handle these two action types. We'll also want to remember to add in a default case, where we return the state. As we mentioned before, with the set search term action, the new term will be passed through as the payload. So here I'll extract that new term equals action.payload. And this new term will be the new value for our state. So I'll simply return new term. When we clear the search term, we want to just reset the state of our search term slice back to an empty string. So I'll simply return an empty string. Now that we've created and exported the slice reducer and the action creators, let's go ahead and add this reducer to our store. So I'll go back into my file system and open up the store.js file. And like the other reducers, I'll need to import it and then combine it into our root reducer. So here I'll start by importing the search term reducer. And I'll just copy this file path structure and then make the appropriate changes. So instead, we'll be looking into the search term folder and the search term slice file. Then I'll need to add it to this object by setting the name of the slice, search term, and matching it with the search term reducer. And finally, we need to go into the app component. Here, we'll need to import the search term component that's already been created for us, and then render it with the appropriate data. So we'll start by importing search term from, and again, following this pattern, I'll be going into the features folder, now the search term folder, and then the search term.js component file. If you'd like, you can find this file in our file structure by going into the search term.js file. And here we can see that this component expects a search term and dispatch prop. So let's go ahead and render this component with those props. It's sort of up to you where you put this, but I'm going to put this below the currency filter feature. Here I'll add in the search term component. And it needs two props. Search term, which is going to be its slice of state, so state.searchTerm, and then dispatch. Let's save our code and test it out. As we can see, the search term component is now being rendered underneath the currency. However, when we search for our product, nothing changes. And that's because we haven't updated the data that's being rendered by the inventory component. To help us with this, we can filter down the state.inventory data using this function getFilteredItems. I'm going to copy and paste that into my app.js file. And as we can see, we can call this by passing in items and search term. So I'll replace the data being passed as the inventory with a call to this function, getFilteredItems, and I'll pass in the inventory and the search term slices of state. Let's save our code and test it out. Now when I type in T, we can see that only the T's are being shown in the inventory. I hope this project provided you with some valuable hands-on experience integrating Redux into a React application. While we did much of the planning and file setup for you, feel free to use this project as a reference to help you create your own React Redux applications. Thanks for watching.